Ever wondered how important operational amplifiers are in our daily lives? Well, we're about to explore that. The story begins in the 1940s, at the heart of Bell Labs, where a man named Carl D. Schwartzel Jr. was hard at work. His goal? To improve the telephone system, a task that required a device capable of better amplification and processing. Enter the operational amplifier. Initially, these amplifiers were made using vacuum tubes, but as technology advanced, so did the operational amplifier. It transitioned to solid-state technology, which was smaller, more efficient, and more reliable. The birth of the operational amplifier was a pivotal moment in electronics. It was born out of necessity, a response to the growing demand for improved communication systems during a time of rapid technological development. Thus, the operational amplifier, born from necessity, has evolved into an essential component of modern electronics. From the early telephone systems to the advanced electronics of today, operational amplifiers, or op-amps, are everywhere. They are the heart, the lifeblood of many circuits, integral to the modern world of electronics. At its core, an op-amp is a high-gain electronic voltage amplifier. It has two input terminals, the inverting and the non-inverting, and a single output terminal. The power supply, which can be dual or single, feeds the op-amp, driving its operation. There are different types of op-amps, each with a specific role. The inverting op-amp, which flips the input signal's phase, is often found in audio equipment, while the non-inverting op-amp maintains the input signal's phase and is used in areas like data acquisition. The differential op-amp, on the other hand, amplifies the difference between two inputs, and you'll often find it in control systems. These versatile little devices have one main job: to amplify weak signals. They take a small voltage input and amplify it to a larger output voltage, but they also wear many other hats. They're used in filtering, where they remove unwanted frequencies from a signal. They're essential in oscillation, creating waveforms like sine waves or square waves. And they're crucial in voltage regulation, maintaining a constant output voltage even when the input or power supply changes. So, whether it's amplifying your guitar's sound or maintaining the correct voltage in your computer, operational amplifiers make it happen. Now that we've seen how op-amps work, let's see how they touch our lives every day. These tiny components are the driving force behind a myriad of modern electronics. They're hiding in our audio and video equipment, handling the signals that bring us our favorite tunes and films. They're integral to our computers, amplifying the binary signals that form the backbone of our digital world. But the reach of operational amplifiers extends far beyond entertainment and computing. In the realm of telecommunications, op-amps ensure our voices travel crystal clear across vast distances. And in the medical field, they're indispensable. EKG machines used to monitor the electrical activity of our hearts rely on op-amps to amplify the tiny signals our bodies produce. The story doesn't stop there. Scientific instruments from spectrometers to oscilloscopes use operational amplifiers to take precise measurements and create accurate readings. They are the unsung heroes, silently working in the background, making our technological world possible. Looking to the future, the role of op-amps is set to grow even more. Ongoing research is exploring the potential uses of operational amplifiers in the rapidly evolving fields of artificial intelligence and Internet of Things devices. Here, they can help to process and amplify the vast amounts of data needed for these technologies to function. From the music we listen to the medical tests we undergo, operational amplifiers play an essential role. They truly are the unsung heroes of electronics. So we've come a long way from the early days of operational amplifiers. Born from the genius of Carl D. Schwartzel Jr. in the mid-20th century, these essential components have grown to become the heart of countless circuits. Today they continue to evolve, finding new applications in our increasingly digital world. From audio equipment to scientific instruments, they're everywhere, working tirelessly behind the scenes. In conclusion, operational amplifiers, these little components, have a big impact, amplifying our lives in more ways than one. They are indeed the building blocks of our digital world,